So very often, too, in sciences, we come across very small numbers, again, numbers that have a lot of zeros in them. And let's take a look at an example. This is the mass of an electron in kilograms. Now, I counted up the zeros here, and just the zeros to the right of the decimal. That was not really going to count here. So I got point, and then I got 30 zeros here, and then 91095. So we want to write this number in a more convenient form, and again, we're going to use scientific notation, which is going to make use of powers of 10. So let's try this. If you write 10 to the negative 1, this is 1 over 10, which is 0.1. If you write 10 to the negative 2, this is 1 over 10 times 1 over 10 again, which is 0.01. Do one more. If you write 10 to the negative 3, you get 1/10 times 1/10 times 1/10, which is 0.001. And we could keep going. So maybe you see a pattern here. The exponent tells me how many places to the right is the 1. So the exponent is negative 1. That 1 is 1 place to the right. Negative 2. We have to go 2 places to the right to get to the 1. Negative 3, the 1 is located 3 places to the right. If it was 10 to the negative 4, we would have 0.1234 places to get to the 1. Now, in our number up here, in this number right here, we have a 9, and just to get to that 9, we're going to have to go how many places? That 9 is going to be located, what, 31. So we're going to have to go 31 places just to get to that 9. So now we can write this very small number here as 9.1095 times 10 to the negative 31. And the negative 31 is indicating how many places we had to move to the right in order to get that non-zero digit there. Remember, the forms look like this. Numbers in scientific form, if you have a non-zero number here, then a decimal point, and then maybe some other numbers over here, and then times 10 to some number. And this number right here has to be non-zero. So it's going to be number is going to be in scientific form if you have a decimal point and then just one non-zero digit to its left. So here's just a couple of examples. We could have something like this. We could have 4.23 times 10 to the negative 8. And just to the left of the decimal point, there's one non-zero digit. We could have maybe 1.405 times 10 to the negative 2. And again, we have one non-zero digit to the left of the decimal point. Let's try a few more where we actually get a number into scientific form. Let's start with this number right here. We have 0 point and a small number. Now what we want to do is we want to move this decimal point 1, 2, 3, 4 places until we can locate it just so that it's to the left of that 8. So we're going to write our number as 8.2 times 10 to the, now how far did we take it to the right? 1, 2, 3, 4. So if I move that decimal point right over here, I'll have one non-zero digit to the left. Right, that's how it goes, one non-zero digit to the left and then some other digits. So I've got one non-zero digit to the left and then my decimal point and then times 10 to the, now we went to the right, so count the number of places, 1, 2, 3, 4. And since we went to the right, it's negative 4. Here's another small number. I want to move the decimal point so that it's right here, right? What I want is 2.19 times 10 to the something. So how far did we move it? 1, 2, 3, 4, 5, 6, 7. But we went to the right, so it's going to be times 10 to the negative 7. Now, look at this number right here. This is not in scientific notation, right? Because we have 3 digits to the left of the decimal point, not just 1. So look what we did to get it here. The exponent is negative, so we must have moved to the right, and we moved to the right 6 places. So what did we do? We started someplace, we went 6 to the right, and we ended up here. Well, it looks like we went too far. So back it off. 5, 4. So we should rewrite this number as 4.321 times 10 to the just the negative 4. What about this number here? This is not in scientific notation because when I look at the decimal point and to the left, I don't have a non-zero digit. So here's what we did to get it here. We moved it to the right, because of the negative. We moved to the right 15 places. So imagine some number. We move the decimal point to the right 15 places, and that takes us right here. But we didn't go far enough. We need to have the decimal here. So to get it here, we went 15, so we must go more. 16, 17, 18. So we're going to write this number now as 2.9 times 10 to the negative 18.